This is a calculation question, so don't be lazy. Make sure you show you're working. Make sure that you check your answer, check your units are coherent, and check through by putting them all through the calculator again to check you haven't made any sloppy powers of 10 errors or anything like that. Check your answer is sensible, but remember sometimes they're trying to ask you to calculate things that do surprise you. I quite like this question really. It's really straightforward. You've given a potential divider circuit. Just remember when you're doing potential dividers, you see this, all you're thinking is, right, I'm sharing that 9 volts in the ratio of these two. This is the output here, and they usually display it in this way around. You're then given a graph showing how this thermistor changes with temperature, okay, and you're probably going to be using this graph to read the resistance at a certain point. You're thinking, well, resistance versus temperature varies with a curve, and it's an exponential curve, but look at the axes and look at the graph paper, they're logarithmic graph paper, so this is this skill. They're expecting you to be able to read off a log scale, and log scales are pretty simple really. If that's 0.1 and that's 1, then each one of these is just the next division between 0.1 and 1. Okay, so we'll do that skill in a second. Firstly though, with reference to charge carriers, explain why the resistance of the thermistor changes with temperature. Well, you know that the resistance goes down, so you know the current goes up. So what happens about the charge carriers when a thermistor gets hotter? Well, all you know about metal resistors, normally the hotter they are, the higher resistance they have. So you know that's because the ions in that lattice, they vibrate more and then they get in the way. But that doesn't happen with thermistors. Well, it does happen. The lattice vibrations do occur, and that does increase resistance somewhat. But what happens a lot more is that the thermistor gets extra charge carriers. I really like the way that one of my students went around this. He actually brought out his transport equation, which I remember as INAV. Current is number of free charge carriers per unit volume times the area times the drift velocity times the charge on one charge carrier. And he said, well, area's fixed, drift velocity, I imagine won't change necessarily, charge certainly won't change. So what needs to increase? N must increase. Number of charge carriers per unit volume. Now, where's the second mark? Explain why the resistance of the thermistor changes with temperature. They haven't said how it changes, and the second mark in this case, how they wrote this question was that therefore resistance decreases exponentially. Don't need that, but there you go. All right, next part is actually trying to solve the potential divider. The heater switch is on when the temperature falls below 20 degrees. Calculate the resistance of the fixed resistor R. So the first thing I suggest you do is redraw or annotate the diagram on the other side of the page. I'm going to redraw it because then I don't have to keep flipping through for you. So you know that you're trying to work out R. You're told there's 9 volts across both of these. So 9 volts is going to be shared out between here, the output to the heater, and here across the thermistor. So that's that, redrawn. What is the value of the thermistor at 20 degrees? You're going to use the graph for that. So 20 degrees up to the line, along here, 0.2, 3, 4, 5, 6, 7, 0.7 kilo ohms. Annotate that on my diagram there. In the question as well, in the stem, you're told the heater switch is on when it's above 5.5 volts. So you know the voltage out here is 5.5. Now you can work this through with Ohm's law, but I just think the simplest way to do this is to think the ratio of the voltage across 1 over the voltage across 2 is equal to the resistance of 1 over the resistance of 2. Easy peasy. So what's the voltage across 1? We don't know that yet, do we? Oh, well, yes we do, because we know voltage across both is 9 volts and resistance is shared in series. So we know the voltage across 1 is 3.5 over 5.5. is equal to the resistance of the first one. I'm just going to call that one 0.7 over the value that we want, R. So type that in the calculator, and actually rearrange for R2 if you like. It's going to be 0.7 over 3.5 over 5.5. I'll just do that like that. I know that's not great maths, but for simplicity's sake, and just show you how I'm going to type that in the calculator. 0.7 divided by 3.5 over 5.5, boom. 11 over 10, simplify that, 1.1, and it's 1.1 kilo ohms because 0.7 was in kilo ohms as well. All right, I hope that makes sense. That's certainly, I think, the simplest way to go about potential dividers. So I hope that was really useful to you. Exam questions are a great way to practice for exams, but don't just do exam questions. If you struggle with that exam question, then you probably need to revisit the theory for that topic. So do that before you have a go at some other ones. If I've made any mistakes, then correct them down below. And if you've got any more questions, then down below as well. Maybe you guys can help each other out. And there should be some playlists around here and a subscribe button if you like that and you want to see some more as I'm going to bring it out. All right, thanks a lot for watching.